Okay, for this video, we're going through light, success criteria D, define refractive index of a medium in terms of the ratio of speed of light in vacuum and in the medium. Now, what is refractive index? So this is the definition. You need to know the refractive index. So we use N, letter N. So refractive index of a medium is defined as the ratio of the speed of light in vacuum to the speed of light in the medium. Now, since it is a ratio, right, of the different speed, okay, so this refractive index has no units. Okay, so if I were to put it into a formula form, it looks like this. Refractive index of a medium is equals to speed of light in vacuum divided by the speed of light in the medium. Okay, now what does N, C and V stands for? Now N, we use it to denote refractive index of the medium. Okay, C is the speed of light in vacuum, while V represents the speed of light in the medium. So it can be confusing to some students because vacuum, it starts with the letter V, but we have the letter V, okay, the symbol being used for the speed of light in medium. Okay, so later on I'll teach you a way to not be confused. Take note of this: the higher the value of the refractive index of a medium, the slower the light travels in a medium, because this is, after all, a ratio of the speed of light in vacuum versus the speed of light in the medium, right? So the higher the value, the slower the light travels in the medium. The minimum value of a refractive index is 1, and the scientists give it to the medium of vacuum. Okay, so therefore the maximum speed of light is 3 times 10 to the power of 8 meter per second. Okay, take note, number 3, the refractive index of air is 1.000293, so it can also approximate to be 1. Okay, because nobody actually stays in vacuum, they stays in air, right? So we can just roughly take it that the refractive index of air, I can write it like that. I can write refractive index of air to be equals to 1. Okay. Now, V represents speed of light in medium and not in vacuum. Take note of that. As refractive index is a ratio, it does not have a unit. Now, going back to point number 2, the minimum value of N is 1. Okay, is given to vacuum. So nothing can be more empty than vacuum. So if in your calculation, let's say you're using N equals to C over V, but you substitute the wrong values inside, that means you mistook C as the speed of light in the medium, while V as the speed of light in vacuum, the other way around, you will get a number smaller than N. Then that is where you know that your formula or your application of the formula is incorrect. Okay, let's do one question. Okay, light of frequency 5 times 10 to the power of 14 Hertz, so this is my F, travels at a speed of 3 times 10 to the power of 8 meter per second in vacuum. So I'll give it a letter C. Okay. Now, what's the frequency and wavelength when it travels through a piece of glass with refractive index of 1.5? So this refractive index of 1.5, I can put as N subscript glass to be 1.5. Okay. Now, this one requires your knowledge that the frequency does not change, right? Because the light is already traveling outwards from vacuum and then it enters glass. Right, so we actually learned in the previous chapter of waves, SSSS, right? The frequency will not change. Okay, because the waves has already gone out from the source. So how can we actually change the frequency? We can't unless we change it at the source. Therefore, options A and B will be incorrect. So it's left with C and D because the frequency will remain the same. Okay, so now we need to find the wavelength. Now we are given frequency, we are given speed, okay, but however this speed is not the speed in glass, so we need to apply this formula. So this is the next step. N equals to C over V. So N glass is 1.5, C is 3 times 10 to the power of 8, and V is the speed of light in the medium, which is actually the glass. So this becomes 3 times 10 to the power 8 over 1.5. So we get 2.0 times 10 to the power of 8. Okay, so this will be the speed of light in glass. And then the last step is, so this is first step, this is second step, and this is a third step. We have to use V equals to F lambda because light is a form of wave, so it obeys this wave equation. So the V is now 2.0 times 10 to the power of 8 equals to frequency. Frequency we have it as 5 times 10 to the power of 14 multiplied by lambda. So lambda will be equals to 2.0 times 10 to the power of 8 over 5 times 10 to the power of 14, which will give us a value of 4 times 10 to the power of minus 7. So answer is C. Okay, so a simple MCQ questions, there can be 3 steps to it. But first of all, you need to know that the frequency will not change to get a start. Then you need to apply this refractive index formula, and finally the wave equation.